Good morning, everyone. Welcome to the class on operation research. And in today's class, we'll discuss the very important concept of simplex method, which is called as big M method. So, guys, I hope you remember when I taught you simplex method, I told you that in the case of simplex method, your objective function is always maximization. Okay. And then when you are trying to solve the problem by simplex method, the constraint what you have that should be less than or equal. I hope you remember that whenever we work on simplex method, the constraint should be either less than or equal to. Here, if you see in this problem, if you see the objective function is minimization, and the constraint here, if you notice, the constraint is greater than or equal to. Okay, so whenever you are trying to solve an LPP problem, and if your constraint is given as greater equal to, then the best way to solve such kind of problem is to use big M method. So normally in such kind of scenario, to get the solution for the problem, we employ big M method to get the answer for such kind of problem. So how we use a big M method to get the answer for this kind of scenario? So let's try to understand that. So here, if you see the objective function is minimization. So converting minima of matrix objective function into maxima objective function is not a big thing. So if your objective function is minimization of z is equal to 12x1 plus 20x2, I can convert this into maximization objective. So to convert this into maximization objective, then your objective function will be minus 12x1 minus 20x2. This we do very easy. So it's not a big thing. Okay, the thing is that what we need to focus more is basically the constraint here. The constraint, whenever we are trying to solve the problem, the constraint should always be less than or equal to. Probably in this problem where your constraint is greater than equal to, so what we can do to get the optimal solution. So first thing what you learned probably whenever you have a simplex method, you learn to convert the linear inequation into linear equation by introducing some dummy variable. So the same thing we'll try to use it here. So first thing I'll convert the minimum objective into maximization objective by writing maximum of z to minus 12x1. I can write here this minus 12x1 minus 20x2 and write as the objective function. Okay, subject to when I talked about constraint, subject to. So here, if you see, you have greater than or equal to constraint. So what you can do to make this linear inequation to equation, you can write 6x1 plus 8x2 minus s1 is equal to 100. Similarly, you can write 7x1 plus 12x2 minus s2 is equal to 120. Okay, so what you are trying to do, you are introducing a negative slack variable. Earlier till now in the problem, when you had a constraint as less than or equal to, you were using a positive slack variable. But because if your constraint is greater than or equal to make the equation balance so that it become equal to your RHS. So you need to introduce negative slack variable where where your constraint, your decision variable x1, x2, your dummy variable s1 and s2 that should be then equal to 0. And you can write this as 0 s1 plus 0 s2. This is how we used to solve a problem, LPP problem, by using simplex method. I hope you'll agree with me. This is how we used to solve. So to make you understand this, why I introduce negative slack variable in case if anyone have any doubt. So guys, please understand, like if your constraint is 6x1 plus 8x2, if that is greater than or equal to 100, so what this mean? If 6x1 plus 8x2, if this is greater than or equal to 100, what this mean? This means that your 6x1 plus 8x2, this is either equal to 100. Okay, this is either equal to 100 or 6x1 plus 8x2, this is greater than 100. If it equal to 100, then there is no problem. Okay, so then your decision variable, dummy variable will be 0. Okay, so you understand, if because ultimately we are trying to make LHS equal to RHS. if this is greater than or equal to, then two possibility comes that 6x1 plus 8x2 is equal to 100. Then there's no problem with that. In case if 6x1 plus 8x2 become greater than 100, in this scenario, what you will do, in case if this is greater than 100, what you will do, you'll introduce a dummy variable s1. Okay, you introduce a dummy variable s1, where you s1 take all the values, where you s1 take all the values from 6x1 plus 8x2 minus 100, where x1 take all the values from 6x1 plus 8x2 minus 100, so that your LHS become equal to RHS. So the objective of introducing this variable is to make the equation where your LHS become equal to RHS. Okay. So I hope you understood this part. So your LHS become equal to RHS in that context. Clear, everyone? So now what you'll do, now with this what you'll do, the moment you get a scenario like this, now with this scenario, what you'll do, you will start the iteration table. You can write them in standard form. So if you can write them in standard form, then you can start the iteration table: 6 8 minus 1 0, then 7 12 0 minus 1, then x1 x2 s1 s2 is equal to 100 comma 120. Okay, so this and then with this, once you write them in matrix form, after writing them in standard form, what you can do, you can start solving the problem. You can start solving the problem. You can write x1 x2 s1 s2. Here you write your RHS. Here you write s1 and s2. Then you can write your variables also. You have 6 8, you have minus 1 0, then you have 7 12 0 minus 1. Your RHS is 100 and 120, and these slack variable having the coefficients, called 0. The coefficients called 0, and the objective function is minus 12x1 minus 12x1 minus 20x2 0 s1 plus 0 s2. Like this, with this you can start solving the problem. Guys, but there's a problem. What is the problem? Problem is that you can never start solving the iteration table with the negative slack variable. That is a problem, guys. Here the problem here is that we cannot solve the problem with the negative slack variable. We cannot initiate the iteration table with the negative slack variable. In case if you try to initiate the equation with the negative slack variable, then you will get non-feasible solution. Here you got negative slack variable. Okay, why you get the negative slack variable? Because your constraint were having less than or equal, your constraint were having greater than equal to sign. So because your constraint was having greater than equal to sign, so what you did, the purpose of using the constraint was to make LHS equal to RHS, and then probably the objective was to start solving the problem by using the iteration table, by starting with the dummy variables. But we cannot use the dummy variable here, like the way how is to solve with less than or equal to, because these dummy variables, what we talked about, these dummy variables, these are basically negative slack variables. So with the negative slack variable, we cannot initiate solving the iteration table. So with this problem, in order to erase the problem what we're facing, because we cannot able to solve them, because with this scenario we cannot able to solve them, and we have to solve the given problem. So what we can do, we can introduce artificial variables. We can introduce artificial variables here, because you have we have two constraints with greater than or equal to sign. Introduce artificial variable which is equal to the number of constraint. The artificial variable you will introduce that depends of the number of constraint having greater than or equal to inequality, having greater than or equal to number of constraint having greater than or equal to sign. So the artificial variable what you will introduce that depends upon the how many constraints are there with greater than or equal to sign. So depending upon how many constraints are there having greater than or equal to sign, with that depending upon that will introduce that many artificial variable. I hope you understanding. So because we need to initiate solving the problem. We cannot initiate solving the problem with the negative slack variable. So what I'll do, I'll introduce artificial variables. I'll introduce artificial variables, suppose A1 and A2. Why A1 and A2? Why only two artificial variable? Because artificial variable totally depends upon how many constraint you are having with greater than equal to sign. So you introduce artificial variable A1 and A2 having coefficients. So having coefficient minus m, okay, which will not impact the solution of the problem, which will not impact the solution, the derivation of the solution of a problem, which will not impact the derivation of solution of a problem. So, so what we are trying to do here, guys, we are because we are having we are facing a problem that we are trying to solve the problem by simplex method, and when we are trying to solve the problem by the simplex method, we are trying to introduce artificial variable in order to solve this problem by simplex method with greater than or equal to constraint. What we did to remove that constraint, we introduced a negative slack variable, but negative slack variable cannot be the part of the iteration table to make sure that we could start solving the problem with some dummy variable, because the iteration table in the simplex method when we are trying to solve it, it start with some dummy variable, okay, and gradually we'll change the value of the dummy variable with some decision variable. But the negative slack variable cannot be introduced into the solution, into the iteration table. If we try to introduce, then we'll get a non-feasible solution. So in order to cover up the situation, ultimately what we need to do, we need to introduce some artificial variables like a1, a2, a3, like that. These artificial variables are having coefficient called minus m. Okay, these artificial variables are having coefficient called minus m, where the objective of introducing these artificial variable with minus one coefficient is to make sure that they should not impact the derivation of the solution of the problem. Because you need to understand here you need to understand the m. When we talk about m is very large number. How to define m is very large number. M is very large number close to infinity. Assume what is m, where m is very large number close to infinity. M is very large number close to infinity. It's not exactly infinity, but it's close to infinity. It approaching infinity. Okay, so minus m will be very small number close to zero. If m is very large number close to infinity, then minus m would be very small value. Minus m would be very small value close to zero. So that the purpose of introducing this many minus m coefficient is to make sure that it should not impact my solution. We don't have to consider these values. The only reason why we are accepting them, we are allowing them to participate, is to initiate the iteration table. For initiating the iteration table, I need some dummy variables. So that dummy variables are basically artificial variables like a1, a2, a3 having coefficient minus m. Because minus m, when we talk about minus m, they are very small values, and they made sure that they do not impact the overall calculation process of getting the optimal solution. Anyone, any doubt? So now the same problem we can write as I'm writing maxima of z is equal to, now the same problem I can write as maxima of z is equal to minus 12x1 minus 20x2. Okay, then subject to, so that will be 6x1 plus 8x2 minus s1. Okay, minus s1 plus a1 is equal to 100. Then you can write as 7x1 plus 12 minus s2 plus a2 equal to 120, where x1, x2, s1, s2, a1, a2 greater than or equal to 0. Okay, plus 0 s1 plus 0 s2 minus ma1 minus ma2. So this will be the way how we write them in the standard form. Clear everyone? So now you have written down the standard form. Once you written down the standard form, you can write that in the form of matrix. Okay, you can write this in the form of matrix. The matrix form, if you write this, it will be 6, 8, minus 1, 1, 6, 8, minus 1, 0, 1, 0. Then this would be 7, 12, 0, minus 1, 0, 1. So this would be x1, S1, S2, A1, A2. You're getting it right. 6, 8, minus 1. Okay, 0, then 1, then 0, then 7, 12, 0, minus 1 into x1, x2, S1, S2, A1, A2. That is equal to your RHS, that is 100 and 120. Clear everyone? So once you are done with this, you can write them in the form of iteration table. Once you're done with this, you can write them iteration table x1, x2, s1, s2, a1, a2. Then you have a1 and then you have a2 with negative value of minus m. That is, this is 6, 8, minus 1, 0, 6, 8, minus 1, 0, 1, 0. Then you have another value in the matrix form, that is 7, 12, 0, minus 1, 7, 12, 0, minus 1, 0, 1. The RHS for the iteration table, RHS for the iteration table will be 100 and 120. That is 100 and 120. And then what you can write, guys, you can write CI values. How will you get the CI values? For the CI value, you simply have to see the coefficient of your objective function. You just see the coefficient of your objective function, you will get the CI value. So minus 12, minus 20, because the objective function was minima. So you need to convert that into maxima, without which you cannot solve the simplex problem. So this was 0, 0, 0, minus m, minus m. Clear, everyone? Anyone have any doubt? Write them. This is equal to Ci. Then find Zi. You know, right, how to find Zi? This will be minus 13m, minus 20m, m, m. Then you have minus m, minus m. Like the way how we used to find, you will find it. Anyone, any doubt? So you can see this. You can, I hope, anyone, any doubt with this? So once you find this, now you can find Ci minus Zi. So this would be 13m minus 12. Okay, this will be 13m minus 12. This will be 20m minus 20. This will be 13m minus 20, 20m minus 20. Okay, then this will be m. Okay, this is already m. Ci minus is 0 minus m. Okay, so then this will be minus m. This will be minus m. This will be 0. This will be 0. Clear, everyone? So out of all Ci minus Zi, I will pick that value which is highest. So you can see the largest value will be 20m minus 20. You don't have to consider this coefficient, guys. Next to m, the whichever is your coefficient, you don't have to consider them because m is very large value. Are you getting me? Because m is very large value. So after that, plus minus and all does not signify anything. Like so that your solution does not depends on that. I hope you are understanding. M is very large value. It's not infinity. If I have taken infinity, then 20 infinity, 13 infinity, both would be same. That's why we don't take it as infinity. I have taken as a M. So I can make a comparison that out of 13m and 20m, which is bigger number. Are you getting this? So theta, this would be 100 by 8. 100 by 8, this will be 12.5. and this would be 120 by 12, that will be equal to 10. So out of all theta, figure out that theta which is minimum. So the theta which is minimum is basically u is a2. So it means a2 will leave the solution and a2 will be replaced by x2. Everyone clear, right? Guys, understand, like imagine if ci minus zi, imagine if ci minus zi, you get 1 as, like, suppose 13m minus 100, and another ci minus zi is 8m minus 4000. So you need to understand that 13m minus 100, that will be bigger than 8m minus 4000, because we need to understand m is very 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 large value. Okay, so there the plus minus next to that does not define which is bigger, which is smaller. So m is very very large value. So here, to determine out of these two number which is bigger number, for that you just need to see the coefficient next to m. I hope you are getting it. This is minus m a1, and then this is minus 20 x2. So the what you say, the theta, yeah, so the pivot element corresponding to this will be 12. So 12 is the pivot element, you know that. So ultimately this value will be 7 by 12. This will be 1, this will be 0, minus 1 by 12, then 0, then 1 by 12, and then this will be 10. I can find the value of a1, new values of a1 I can find, new values of a1 I can find, new values of a1 I can find, new values of a1 I can find. A1 old values, old element value is 6, 8, minus 1, 0, 1, 6, 8, 6, 8, minus 1, 0, 1, 0, 1, 0, 100, and then the new element of x2 is 7 by 12, 1, 0, minus 1 by 12, 0, 1 by 12, 10. Then the constant here is 8. The constant here is 8. So the 8 is the constant. So we will, to find the new values of A1, we'll use a formula called old element minus 8 into new element of x2, that is 6 minus 8 into 7 by 12, that is 6 minus 2 into 7 by 3. This is 6 minus 14 by 3, means 4 by 3. And this is 8 minus 8, that is equal to 0. Then this is minus 1, because that the other part is 0. Then this is minus minus plus, no, 2 by 3, 8 by 12. And then this would be 1. This would be minus 8 by 12, minus 2 by 3. And then this would be 100 minus 8 into 10. This will be equal to 20. 4 by 3, 0 minus 1. 4 by 3, 0 minus 1. 2 by 3, 1. Minus 2 by 3, 20. Minus 2 by 3, 20. Now you can find Zi value. You can find Zi value. So to find the Zi value, this would be minus 4m by 3 minus 140 by 12. This would be minus 4 by 3m minus 140 by 12. Zi value, this would be minus 20. Then this would be m. Then this would be minus 2m by 3 plus 20 by 2. This is minus 2m by 3 plus 20 by 2. Then this is minus m. Then this is 2m by 3. So this is minus m. This is 2m by 3 minus 20 by 12. 2m by 3 minus 20 by 12. Then this is minus. This is minus 20m minus 200 minus 20m minus 200. So these are the Zi values. Now you can find Ci minus Zi. Before I find Ci minus Zi, let me write down the Ci values. Ci values are minus 12, 20, minus 12, 20, minus 20, then 0, 0, 0, 0, then minus n, minus n. So Ci minus Zi is 4m by 3 plus 140 by 12 minus 12. So 4m by 3 plus 12, 140 minus 144. So this is 4m by 3 minus 4 by 12, or 4m by 3 minus 1 by 12, minus 1 by 3. So you can write 4m by 3 minus 1 by 3. You can write like this. This is 4m by 3 minus 1 by 3. Ci minus Zi. Then Ci minus, this is 0. This is minus m. Then this is 2m by 3. Okay. Minus 20 by 12. Correct. So this is 2m by 3 minus 5 by 3. 2m by 3 minus 5 by 3. is 0. So this is minus 2m by 3 plus 20 by 12 minus m. So this is minus 5 by 3m plus 5 by 3. Minus 5 by 3m plus 5 by 3. So you can do that. You can write down the values. C zi, you can see Ci minus Zi. So which is a larger value? You can see this. So all are negative. This here m is negative. Here it is positive. This is positive. This is positive, and this is positive. Out of these two, the larger value is this. So means this will enter into the solution. This will enter into the solution. So if you enter into the solution, then you can find the theta. Theta would be 20 divided by 4 by 3 means 15. And theta here would be 10 divided by 7 by 12. 10 divided by 7 by 12. That would be 120 by 7. 120 by 7 means 1s are 50, 17 point something. So 120 by 7. 7 is 119. So the least value, the smallest value of theta correspond to 15. It means which one variable will exit the solution. E1 will exit the solution, and your pivot element will be 4 by 3. Clear, everyone? So in place of A1, x1 will come. X1 with coefficient minus 12. In place of A1, x1 will come with coefficient minus 12. So where the pivot element is 4 by 3. This is 1, 0, minus 3 by 4. Then 2 by 3 by 4 by 3 means 1 by 2. Then 1 divided by 4 by 3 means 3 by 4. And minus 2 by 3 by 4 by 3 means minus 1 by 2. And 20 divided by 4 by 3 is 15. This is minus 20 h2. Clear, everyone? Now this I got the new values of x1. Now I have to find the new values of x2. So x2 old values were 7 by 12, then 1, 0, minus 1 by 12, then 0, 1 by 12, and then 10. So the new values what you get, the new values what we get for x2, that this is 1, 0, minus 3 by 4, 1 by 2, 3 by 4, minus 1 by 2, and 15. Okay, guys, so the constant here for the x2, the constant is 7 by 12. So your formula would be old element minus 7 by 12 of new element. So this will be 0, this will be 1, minus minus plus, 7 by 12 into 3 by 4. So this is 4 3 are 12 now. This is 7 by 16. Then this is minus 1 by 12 minus 7 by 12, then 1 by 2. This is minus 1 by 12 minus 7 by 12 into 1 by 2. So this is minus 1 by 12 minus 7 by 24. 24 LCM, minus 9 by 24 and minus 3 by 8. Any doubt, anyone? Anyone, any doubt? See the calculation, simple calculation we need to do. 1 by 12 minus minus plus 7 by 12 into 1 by 2 minus minus plus minus minus plus. This is 1 by 12 plus 7 by 24. So 9 by 24 means 3 by 8. Then 10 minus 7 by 12 into 15. 10 minus 35 by 4 is equal to 5 by 4. So you can write down this value 0, 1, 7 by 16, 0, 1, 7 by 16, 0, 1, 7 by 16, minus 3 by 8, minus 7 by 16, minus 3 by 8, minus 3 by 8, minus 3 by 8, minus 7 by 16, minus 3 by 8, minus 7 by 16, 3 by 8, 5 by 4, 3 by 8, 5 by 4. Clear, everyone? Zi value, this is minus 12, minus 20, this is 12 into 3 by 4. So this is 3 0, 2, this is 3 into 3 9. Then this is, and this is what, minus 140 by 16, minus 140 by 16, minus 140 by 16. So 16 nines are 144. No, so 4 by 16, 1 by 4. Then this is minus 6, and this is 60 by 8 plus 60 by 8. So this will be 48 now. This will 12 by 8. 12 by 8 means 3 by 2. Then this is again this is minus 9. Again this is minus 9. This is plus 140 by 16. 40 by 16. So this will be minus 4 by 16 minus 1 by 4. Then this is 6, and this is minus 60 by 8. So this will be minus 12 by 8, means minus 3 by 2. Then this is minus 180. Okay, and this is minus 5 5s are 5 5s are 25. Minus 225. Minus 225. 15 into 12 is 180, right? Yeah. Yeah. So this is 557. So this is minus 205. So you can find CI value. CI values, you can write CI values. CI value minus 12, minus 20, minus 12, minus 20, 0, 0, minus M, minus N. CI minus ZI, if you see, 0, 0, minus 1 by 4, minus 3 by 2. This is minus M plus whatever doesn't matter, minus M plus whatever doesn't matter. I think you can understand, you get the optimal solution. All your CI minus ZI is either 0 or either it is either 0 or either negative. So the final solution, guys, so your final solution is your x1 is equal to 15, your x2 is equal to 5 by 4, and the maxima of z is equal to minus 205. But your objective function was minima of z, that would be equal to 205. This is your final solution, and we got the answer. Anyone, any doubt? Anyone, any doubt? So this much from the today class. We'll continue discussion in next class. Thank you, everyone. I'll see you all in next class. Take care. Bye, everyone.